What's up, everybody? Another video for you. This one shouldn't be too bad at all. Kind of an easy unit so far. Let's do a little recall here. It says describe the shape of the distribution. The options we have here are skewed, and then we have left and right. We have symmetric, if it's the same on both sides. And then we have uniform. If it is kind of just straight across. So when we look at this one right here, it's the same on both sides. So this one would be symmetrical. Right here, we want to think about if we drop the ball, where would it go? Well, it's going to go down the hill to the left. So this would be skewed left. This one right here, we'd go like this. Since we have this outlier out here, we would be skewed to the right. And then another example right here of symmetrical, since it's fairly similar on both sides. All right, so let's talk about central tendencies a little bit. Depending on the shape of the distribution, the types of measurements that we want to use can change. So as you can see, this first one over here, mode being the most frequent, we can see this is the highest point of our graph because it's the most frequent response. But since we have some numbers down here, it's going to drag our average, which again, mean means average, way down here. So sometimes we don't want to use mean to represent our data, because if we use this number down here, that's not really a good representation of our data, because most of our data is here and our mean is way down here. So that's not really a good representation. Whereas when it's symmetrical, we can see that the mean, median, and mode are all going to be fairly in the middle because there's an equal amount of data on both sides. And then when we have it on this side, you can see again, now that it's skewed, our mean is much higher, right? These are going to be higher numbers, much higher than where most of our data is, which is when median comes more in hand, because that's the middle of our data, not the average of our data. Okay, so when do we use mode as our best mode of center? Well, it's going to be when it's categorical, or when we're dealing with characteristics. So this would be something like if you're taking a survey of the eye color of different people. We would be more interested in what eye color had the most responses, right? Did most people have green or blue eyes or whatever it might be? We're not worried about the average eye color, right? Average is not going to help us when it comes to eye color. So again, mode has no measure of spread. So that's why mode represents this data well, because it would show us which one has the most. Now, when you have symmetrical like this, mean is going to be good because it's the middle of our data, and you do get a really good representation of what's going on both sides when you get that mean. And you're going to use this, like it says right here, when it is symmetric or uniform. Because symmetric is, of course, this one that we see right up here, kind of curve up and down, and then uniform is going to be straight across. So that's when we are going to use the mean. Now, whenever we use mean as our measure of center, standard deviation goes with mean. So standard deviation and mean, they go together. Standard deviation describes the spread, so how spread out the data is from the center. So you'll see certain graphs where like this dotted line represents 1 standard deviation, and then this would be 2, and then 3, and it would be the same on both sides here. All right, so whenever you're dealing with mean, you're going to use standard deviation to describe the spread. And then median is best when it's skewed left or right. And the reason for this, and it says it right down here at the bottom, is because of outliers. We talked a little bit about this last week. An example here for you. Let's say our average test score is somewhere right around here in like the 70s, right? So most people on the test got around a 70%. But then so I'll write a 70 here. But I got like maybe one person out here that got like a 99%. Now, is this 99 a good representation of the mean? Well, no, right? Or a good representation of the class as a whole? No, because most people got right around 70 here. This 99, all that does is it drags your mean higher, even though that's not a great representation of your data. So instead, we're going to use the median, because the median is much closer, as you can see right here, to the actual representation of our data. So whenever our data is skewed, we are going to use the median. Okay, it doesn't matter if it's going to be skewed left or right, we are still just going to use the median. So when we use the median, we are going to use the interquartile range, which we used yesterday when I was there. This is when you do Q3 minus Q1. This is how you get IQR. So this will tell you kind of like the spread of the data, just like standard deviation does. Again, standard deviation we can only get in our calculator. IQR we can also get in our calculator, but we don't necessarily need to. All right. So what do we need to know? We need to know, to narrow it all down, when it's, we don't need to use that thick of a pen here. There we go. When it is symmetrical, symmetric / uniform, we are going to use the mean, which in turn means that we're going to use standard deviation. Whoops. Standard deviation. Okay. And then when we have any type of skewed data, when it's skewed either left or right, it doesn't matter. You're going to use the median and IQR to again avoid having those outliers, those bigger numbers or the smaller numbers change your data too heavily. All right, let's take a look at this next page. So it says, describe each distribution using shape, then determine the best measure of center and spread. So this data right here, we could see we draw our little line over it, and then we have these data points way out here. We can see most of our data is over here, but we do have these couple data points out here. This obviously would be skewed to the right. And whenever our data is skewed, we're going to use the median as our center. Okay, so this would be, we would use the median, and the reasoning that we would use the median is because we have these numbers out here that don't really represent the what most of the data is, right? So age of best actress award winners, we can see most of them are right here in this area between 25 and 40. But if we include these numbers out here in our average, it's going to drag our mean, and it's going to make it seem like the average person was in there like between 45 and 50. But that's not really the case at all. So that's not a great representation of our data. And so when we use the median to use our to describe our spread, we would do the IQR. All right, let's take a look here. So box plots like we saw yesterday. This right here is the median, and we can see it's the same on both sides, right? So this would be a symmetric graph, symmetric or symmetrical, whichever you'd like to say. And when we use a symmetric graph, we are going to use the mean as our center, because there's going to be equal amount of data on both sides, so the mean will be a good way to describe the distribution. And whenever we do mean, we are going to do standard deviation as well for our spread. All right, so mean and standard deviation go together, and then median and IQR go together. All right, let's take a look here at this one. Let's look at what we're dealing with. It says favorite color. In this case, this is categorical. This is a categorical data. So if it's categorical, then we're not worried about an average or anything like that. We're just worried about which one has the most frequency. So in this case, yellow has the highest, right? Yellow would be our mode, and so in this case, mode would be best. So whenever we're dealing with categorical data, we're going to use mode. All right. It says create a display for each data set and describe the shape, then determine the best measure of center and spread. So we got number of siblings, and all the numbers are between 0 and 4. So I think the best one for this is going to be just a line plot. So what we can do is we can just draw a line here, and down on the bottom we can just label this 0, 1, 2, 3, and 4. And of course we got to put a little title on here, so we'll say number of siblings, and then up on the left side is just going to be frequency. So let's take a look here. We can go through. Let's count the number of zeros. I kind of like doing it that way. We got 1, 2, 3 zeros, so I'll do 1, 2, 3 X's. Now on to the ones. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 2 siblings. 1, 2, 3, 4 people had 2 siblings. 1, 2, 3, 4. How many people had 3 siblings? 1, 2, 3, 4 people had 3 siblings. And then how many had 4? It looks like 1, 2, just 2. So our data would look something like that. And so now using this to describe our spread, we can see it's a little bit here, and then it kind of tails off this way here. So this would be skewed to the right. Skewed out here to the right, because if we drop the ball would fall this way. All right, so that's our line plot. Now, what does this mean? If our data is skewed, what are we going to use to describe a center and spread? Well, whenever it's skewed, we are going to use median to avoid the outliers, and with median, we use IQR. All right, moving right along. Price of a gallon of gas, it looks like we're ranging from about $3.15 all the way up to $4.98. I think a good plot here would be maybe a histogram, just because of how spread out the data is. This one over here, we just had like 5 different options, but this one, these are all look a little bit different. So you're going to draw your L. So let's see if we can get this kind of nice. There we go. Down here on the bottom is going to be price of gallon of gas, I'll just say price of gas, and then over here will be your frequency. So we just need a couple tallies here, 1, 2, 3, 4, maybe something like that. And so we got to figure out our little range here. So in order to do this, we need to know the number of intervals, and this is an approximation and more just a way to find the bottom number for when we're finding our interval length. But the way we do this is the square root of the number of data values. So we got 1, 2, 3, 4, 5, 6, 7, 8. So 8 data values, so we're going to deal with the square root of 8. And if we type this in, this is approximately 3. So we're expecting to have 3 intervals down here, but we'll just have to see. Now if we do the interval length, which is going to tell us, are we going from 315 to 325, or is it 315 to 370? We're not really sure yet. What you're going to do, again, here's max minus your min, and then divided by the number of intervals. So the maximum number we have here looks like 498. So 4.98 minus our minimum, which looks like 3.15 over, and then this is where this number right here comes in, the number of intervals. So if I was to type this in my calculator, I would get that the interval length is approximately 0.61, 0.61. All right. Sweet. So our interval here is going to look a little something like this. Up the top here, we got 1, 2, 3, and 4. And we got to figure out what numbers are going to go in each interval. So we start down here at 315, and we're going to go from 315 all the way up into, well, let's see. If we're starting at 315 and we're going to add 0.61, I think that's going to give us, let's take a look here, finding the key. Yeah, so we'll go from 3.15 and then we add the 0.61, and that's going to put us at 3.76. So for this first section, we're looking for how many numbers do we have between 3.15 and 3.76. So if we look through here, we got 1, 2, 3 of them. All right, so I'm going to draw this here, and then there's a line straight up here. So let's go there. And that's one of our little plots there. And so now we're going to go from 3.77, and if we add 0.61 to that, we'll get 4.38. So we're looking between 377 and 438. So 377, there's 1, and then 438 would just be those two. And then the last one would be between $4.39 and $5. And it does encompass all of our data values, so we're not going to need anything over here, which is good. And it looks like we just have 3 numbers left here. So 3 numbers left here. Sweet. So we got 3 in the first set, 2 in the second, and then 3 in the third. And if you want to describe your data here, you can kind of see it's just uniform. It's very simple. It's kind of an even distribution, and so whenever it's uniform, you're going to use mean and standard deviation as your ways of describing center and spread. All right, so to kind of go back through this, I know it's kind of quick and also hard on a video, but if it's symmetric or uniform, you use mean because you're not worried about outliers because there really aren't any here. But as soon as there is a skewed set of data, so it's skewed if it's going to the left or to the right, now we're worried about these numbers that are higher than others. That's going to drag our mean away from where our data actually is. All right, so when we're doing that, we're going to use median because we're able to get rid of those outliers, and then we'll use IQR as our measure of spread.